Hi, in this tutorial we're going to look at a simple experiment which is a lid-driven cavity flow. We're going to limit this to two-dimensional analysis and we're going to use ANSYS Fluent. We'll make our geometry in DesignModeler. So we're going to, before we open DesignModeler, let's just right click and look at the properties of our analysis. And the reason I do that is so when I click on the geometry, I can change the analysis type from 3D to 2D. Then I can right click on geometry and I'm going to use DesignModeler. This is my first time using ANSYS 2024, so I need to allow access. Right, in terms of the geometry, this is one of the simpler things that we need to create in DesignModeler, so this will be a good way to get started. The first thing we're going to do is select the XY plane and select look at it. That's changed the view of our screen here, and we can see our scale window down at the bottom middle of the screen. We're going to zoom in and we're going to draw a box. So we've got this now set to a 1 meter scale. I'm selecting the sketching tools and I'm going to draw a rectangle. I move over to the point, which is the origin, so you can see the symbol changes to P. I'll do one click. I'll move my mouse away and do my second click, and now we've got our rectangle. I'll go to dimensions and I'll use the general dimension tool to add a dimension to the side and top of the cavity. And I'm going to make the height and the width as 0.5 meters. The next thing I'll do is I'm going to make a surface from sketch. I'll expand this plus symbol on the XY plane. That's selecting my sketch. I'll press apply, and once we've selected our sketch, we press generate, and now we've made a surface from this sketch. That's all we need to do in terms of the geometry creation. We can make some name selections here as well. I'm going to use the edge select tool here. I'm going to select each of these faces, or each of these edges, sorry. Right click and use the name selection. I'm going to call these walls. I'll press generate again. I'll do the same for the top. The reason I've done this separate is this is going to be a moving wall, so we'll name that as such. And if we go now into our surface body, I'm going to make this instead of solid, we're going to change that to fluid. That's all done now. We've created our simple geometry with sides of 0.5 meters. So we can close that down. We'll go to the next step, which is meshing. Now the first thing I'm going to do now is generate a mesh. I'm not changing any of the settings because I want to show you how we can use mesh controls to affect the final generated mesh. So you can see here we've actually got quite a good structured mesh by default, but we want to add some sizing controls. So I'm going to insert sizing, and I'm just going to select everything. In fact, I just wanted the edges, so let me select all these edges. That should be 4 edges. And instead of element size, I'm going to select number of divisions. Then I can select 75 for each side, so the total number of elements will be 75 squared. So if we press generate now, we'll see what happens. You can see now we've got a unstructured mesh. So let's add another control in here. Let's go insert and let's go for a face mesh. We'll use a single select, we'll press this face, we'll generate the mesh and see how this looks. There you go, we can see we've got our nice structured mesh here. We look at our name selections, we can see we've got our walls and we've got our moving wall at the top as well. So we've got a good quality mesh. The next thing we need to do is press update. And we can see that the mesh translation to Fluent was successful. That's the message we want to see before we close the meshing window and we go ahead to setup. I'm going to enable double precision, and with this licensed version of ANSYS I'm allowed to use 4 processors, so that's what I'll do to speed up the simulation. Now we're going to change a few of the settings. We're not going to change the model, but we will change the material. So I'm going to expand the fluid, double click air and open the Fluent database. I'm going to go to the bottom where we can see water liquid and press copy, close, close. So we've just imported the material but we've not applied it to the domain. So that's what we're going to do in the cell zone conditions option. I'm going to expand my cell zone condition, select my material as water liquid and press apply. I'm then going to open the boundary conditions box and you can see we've got our internal and our walls. I'm going to go ahead to our moving wall boundary condition. So by default walls will be stationary, but we want to make this a moving wall. Now we want this to be moving at a speed of 0.1 meters per second. I've chosen that arbitrarily. We can compute the Reynolds number afterwards. But that's moving in the X direction, which is from the left to the right in this model here. So we're going to apply that boundary condition. If we want to work out what the Reynolds number is going to be for this flow, we'll just open up our water liquid properties and we can see that our density is 998.2 kilograms per meters cubed and our viscosity is 0.001003 kilograms per meter per second. Our other parameters we've got in computing our Reynolds number are the velocity that we just applied of the moving wall, which was 0.1, and our length, which is the length of the side of the cavity, which is 0.5, all using SI units. So if we compute our Reynolds number, which is the velocity times the length times the density, which is 998.2, if we divide that by the viscosity, there we go, 49,000. So we've got still quite a large Reynolds number, so we'll need to be using a turbulent model, which we are by default. So we'll apply this, and now we're ready to initialize and run the simulation. I'm just going to use the hybrid initialization and run the calculation for 200 iterations. This should be quite quick to compute as it's only a 2D case. Excellent, so we actually have a converged simulation here. What does a converged simulation mean? It means each one of these residuals has reached a value below 1e to the negative 3, and we can see those values printed in this window here. So we've run our simulation. Let's look at some results. We're going to make a contour, and we're going to make a contour of the velocity. I don't need to select a surface. I can just press save and display, and we can see we've got high velocity magnitude at the top because that's the moving wall, and then we can see we've got some recirculation happening inside the cavity. We could also do a vector visualization. We'll keep the settings as default, press save and display, and here we can see the vectors of the velocity inside the cavity. So that's everything for now for this simple 2D tutorial. Thank you for listening.